better.
Ira has more potential.
यार पर कभी सोचा है कि एग्जाम्स में बेहतर करने की जिम्मेदारी सिर्फ बच्चों की ही क्यों? इसलिए वेदांतु इंप्रूवमेंट प्रॉमिस।
अब वेदांतु मार्क्स बढ़ाने की जिम्मेदारी लेगा और गारंटी देगा, वरना आपकी पूरी फीस वापस।
वाह, ये होती है गारंटी।
Excellent.
Hello, hi, namaste. This is Surabhi, your chemistry master teacher at Vedantu. Welcome to the session. And you know what? We are starting right away with the Menti quick recap of what you all studied in this series in the last session, A to Z chemistry. I guess Divyasha Ma'am taught you about hydrogen spectrum, isn't it? Yes? Come on, let's start the Menti. Hello everyone, and here is the Menti code 96856134. You have attended the previous session of A to Z? Then only you can answer these questions. ठीक है? Come on. And thank you so much for attending the session. Make sure to subscribe to the channel if you haven't yet. Hit the like button, share this video with your friends, and Surabhi Ma'am is waiting for all of you here. Thank you so much. So you know the Menti code, it is 96856134. It's okay, we'll just give it a try. And today's topic I will be teaching, and it is so interesting. You'll be like, at the end of the session, I'm sure most of you will be like, whoa, I didn't know that. I am doing good, thank you so much. हाँ, tomorrow's session तो होगा जबरदस्त. Come on, I'm still waiting. Okay, yes. Wait, please, Hanji, I'm waiting. Still waiting. After few moments, still waiting. Hanji, hydrogen spectrum. Let's see. Joined, everyone? Yes. Go to www.menti.com and use the code 96856134. We are starting with the quick recap of what you had studied in the previous session of A to Z series. Okay? Joined? Chalo then, all the very best. Here's the first question. Okay, no, we have to see the emojis, right? So there are 9 questions, but only 3 at the beginning. Quick recap hoga, and using the same link, we will be playing the quiz later. So once we have studied 2 important topics in today's session, we will be playing the Menti again. Okay, so do not leave it so that you can carry your points to the next question and you can be on leaderboard. All the very best. Yes, ICB and unicorn, burger, donuts, watermelon. Watermelon Divyasha ma'am hai kya? She loves watermelon, na? It's okay. Donut is you. Your football, okay? We are starting. All the best. Come on, give me a high five. Let's do it. Okay. Which of the following is true regarding the Bohr model of atoms which you learned in the previous session? Assumes that the angular momentum of electrons is quantized, uses Faraday's law, predicts continuous emission spectra for atoms, predicts same emission spectra for all types of atoms. Which of the following statement is true regarding the Bohr model of atoms? What do you think? Okay. No hints. Hi, Hansata. Whoa, not bad. See, you remember. Very good. That's nice. Let's see who do we have on the leaderboard. Okay, next question के बाद. When an atom jumps from its orbit to another orbit, energy is emitted only, absorbed only, no effect, emitted or absorbed. What happens when an electron jumps from its orbit to another orbit? We have not told you anything about the energy levels, right? है ना? Higher energy level होता होगा तो it needs energy, so it will absorb. If it is moving to the lower energy level, then it will be emitted, right? So it can be both emitted or absorbed. As they have not mentioned the orbit energy level, how can you know? है ना? Right? You thought right but voted wrong. Very good. So on the leaderboard we have, let's see, Hari, Harsimran, Polestar, high five, Mark, high five, Sakshi, Sakshi Samant, Srilata, Surabhi Ma'am's radical, Harry Potter, love you ma'am, Surabhi Ma'am loves you too, Cincy, Mars, and Sai Pranav here. Hello there. Okay, so question number 3. I really hope this is also recap. Yes. Which of the following series in the spectrum of hydrogen lies in the visible region of electromagnetic spectrum? So I guess you had solved a few numericals based on this as well, right? In the previous session, I was there for a few minutes. Think. So, hello. Hi. Whoa, goody, good. Come on, give me a high five. So, we did good, right? What do you think? Happy with the result? Even though few of you got confused, but we tried. So, I want the same effort in our next Menti as well. Okay? Yes? Chalo, now what we have to do is let's study something like our particle and wave nature. So you have learned about light. Who taught you? Abhishek sir? Almost when Abhishek sir has taught you light, right? Light chapter, है ना? So what do you think? Light behaves as particle or wave? Of course, okay. Light behaves as particle or wave? Both. How can you say it? Give me a proof, because my physics is not that good, and Abhishek sir though he has never taught me. Even though I keep asking him, I tell him, okay, to teach physics to Surabhi Ma'am. Both. Why? Photoelectric effects. So firstly, it has wavelength, right? It has wavelength, and that diffraction, so wave nature, and it has those packets of energy, so it has to behave as a particle as well, right? Am I right? Hannah? Correct me if I'm wrong. This is what I remember. Hi Snehakshu, hello. Yes or no? Shake sir. So today we will try to see electron का भी दोनों behavior है, that is it behaves as particle as well as wave. What do you think? Yes or no? Yes? You tell him to teach. That he has been already doing it, right? Hey Netak, Hannah, yes. So you are saying yes. But we need proof, right? In science, we always look for the evidence. We want to see those experimentations and the theories and long derivations. So let's see what do we have for today. And after that quick recap, welcome to the session. What we will be learning in today's session is particle and wave nature of electron. Because I'm sure you have already learned about particle and wave nature of light in physics. But is that the same or is it anywhere different? Because once you start learning about it, you will start questioning whatever you have learned in those lower grades. We draw like where is this pen? There will be nucleus, ma'am, and then around the electrons will be revolving in the fixed orbits. Do you think it is fixed? Because if it is behaving as a wave, then we are not very sure, right? Hannah? Yes. Hello everyone. Hello. Hi. Okay. So let's see what happened. How did they come to this conclusion that electrons behave as particle and wave? So here there are two topics which we will be covering, which is very, very important for your competitive exams, especially for JEE. So please note it down. Okay? Yes. So the French physicist, like here in physical chemistry, there are a lot of collaborations between physics and chemistry. It overlaps. Whatever the topics you will be learning in physics, we are trying to apply the same for the microscopic. In physics, it's usually macroscopic. This body is moving at this speed, like okay, Hudson is driving a jeep and then he will hit someone and all that. Right? It is at the macroscopic level. But here in chemistry, we are using the same concepts. We are trying to apply it for the microscopic particles like electrons. Hannah? Yes, so nobody is driving anything, no one is hitting anything here. So it's only electrons and electrons. If you want me to name electrons, I can do that for you. That is all. Okay. So what he said, he was like, देखो. So light has dual behavior. Then even electrons, like radiations, should also exhibit that dual behavior. That is, it has properties of both particle and wave-like. Before we jump to like how, the derivations where we are saying, okay, this means momentum and velocity and wavelength and all that. So what exactly do you understand by the term particle and wave-like? That is very important. Right? That is very, very important. So what is the meaning of particle and wave-like? I'm sure you know about diffraction and photoelectric effect, all those things. But what is the basics of this entire topic in the quantum chemistry? What is the meaning of particle? Yes. Can I know? What do you think? What is the meaning of particle and wave-like? Small circles and waves are lines. Okay. So now usually we used to play these games, like there will be 3 cups and you will add or put a chocolate or money in one of, and then you will just and then you will ask someone, okay, Bhumi, where is the coin or where is the chocolate? You are certain it cannot be in all the 3 cups, under all the 3 cups. It will be present in under only one. Right? That is, you are very certain, because particle cannot be everywhere at one point. But when it comes to wave, there are valleys and all that. So how will you say the exact position? This is the major difference between particle and wave-like. So what happens when you combine both? When you are saying they exhibit both the properties, particle and wave-like. Hello everyone. Hello. Okay. So every matter has particles, Yes, because these particles have mass. I mean electron, proton, it has mass. Right? Yes, very good. Example, particles like chili powder and wave. Wave like Maggie. Good one. So what de Broglie did later, he assumed, okay, there must be electron का भी dual behavior है, that is, it will behave as particle and wave. So he gave us this relation. It is between, wavelength and momentum of a particle. So what is this? H is Planck's constant and P is momentum and lambda is wavelength. I am sure you are good at it, right? Yes. Right? Okay. So what is this de Broglie wavelength? You have lambda. Lambda is wavelength, right? So h by mv. We all know momentum is equal to mass into velocity. Do we? Yes? If you don't, then I'll call Abhishek sir. What is this? No, Harsimran, no. Hello, Ananya. Hi. So P is equal to m into v, that is mass into velocity. Okay, this is momentum. So what is the relationship between lambda, mass and velocity, or lambda and momentum? Is equal to lambda is equal to h by p, that is h is a Planck's constant. What is its value? I want you to tell me in the comment section. It was not in your syllabus, no, but still you should know. That is all. Now, what is this real behavior of matter? According to de Broglie, every object in motion has a wave character. What? Okay, so I'm throwing something at you. I'm like, shh, catch this ball. Do you think it has wave nature? Because particle nature, yes. But what about wave nature? Yes. Do you think when an elephant is running towards you and you are running for your life, you have wavelength or the elephant has wavelength? What do you think? Yes or no? Particle nature, तो we are very sure. हाँ जी, particle nature है. But what about the wave nature? Yes, we do have. Right? Sure about that? Let's call Abhi said no. Acha. Okay. You know, right? So we don't know. Yes, it is in motion, but does it have wavelength? Yes, it will. But the wavelength is so short that, like it is billionth of trillion in meters. So it is like you can't measure it. Every substance, every matter will have wavelength, but in those macroscopic objects like ball or elephant, it will be very short because of their large masses, because they have momentum, right? They have mass, but the wavelength will be very short. As I told, when you try to measure it, it will be very short. That is the reason wave part properties of those macroscopic or large or ordinary objects cannot be detected. Yes, we can't measure it, that is all. See, in science, one thing you have to believe all the time. Okay, if you cannot see it, that doesn't mean it won't exist, right? It does. We have other proofs. They have small light of Doraemon. What? Doraemon? Why did Doraemon come here all of a sudden? Okay. So the wavelengths associated with ordinary objects are so short. Did you get this point? It is important. Yes or no? Yes? Very good. But in case of microscopic particles like our subatomic particles, electrons, protons, so as they have very small mass, see, even when we are talking about the mass of an atom, we are neglecting the mass of electron, right? Because it is like, hey, it is so small, let's just leave it there. So because of its small mass, the wave properties of these microscopic substances, particles like our subatomic particles, electrons, can be detected experimentally, and it has been detected already. Okay? Yes? Clear? Okay. So see, if you are talking about microorganisms, right? It all depends on, yes, everything behaves like a wave, but it can be detected in very few particles if they are microscopic. Okay? So the wave nature of macroscopic objects is unobservable because the de Broglie wavelengths are too short. Yes. Okay. So next is one more very important concept, that is Heisenberg's uncertainty principle. So what do you think? What is the meaning of uncertainty? Yes. Not yet, Malhar, but I will. Yes. Can you tell me what is the meaning of uncertainty? Okay. Did you understand? De Broglie wavelength? Yes? Yes or no? Yes, I can only tell you the probability. The electron might be here, I'm not very sure. You cannot say it by that certainty. है ना? Yes? Very good. Now what is this Heisenberg's uncertainty principle states? This statement is very important. You will get the notes. So I am very sure JEE competitive exam mein and in your boards also. So one question will be asked from these topics. It states that it is impossible to determine simultaneously what? The exact position and exact momentum or velocity of an electron. Right, okay. I'm like, okay, the electron might be here, but it is moving. How can you tell about its velocity? So with that certainty, you can't determine both. It is here and its velocity is this. No, it is impossible. So that is what Heisenberg's uncertainty principle states. Yes? Okay. So it states that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. See here, we are not very sure. That is the reason I can give you that probability. So this, it might be here and this might be its velocity. This might be its position. And this is again important. Delta x, delta p greater than or equal to h by 4 pi. So delta x is uncertainty of position and uncertainty of momentum. Good one. So now see, incident photon and the scattered photon, right? So using this picture, you can try to maybe understand, okay, what exactly this uncertainty is. You have two things. I want you to tell me about the momentum, that is velocity, and the position of electron at a time. So at this time, where is the electron and with what velocity is it moving? But it is impossible for you to state that. Okay, that is what this statement is. It looks complicated. Why? Yes, I know, right? Many of you are spamming. क्या हो गया? Okay. So it rules out the existence of definite paths or trajectories of electrons and other similar properties. So paths, trajectories of electrons, and so that means, are they moving in these definite orbits? How can you be so sure? Because it is behaving as a wave and particle, and you can't tell where exactly the electron and what is its velocity simultaneously. So the path. Yes. So about the photoelectric effect, Divyasha ma'am in the next session she will be covering photoelectric effect. Don't worry. Okay, it is very important. Yes, that's my UPS. And one more important thing again. So this Heisenberg uncertainty principle is significant only for motion of microscopic objects. For macroscopic, no, it is negligible. Okay? Clear? Everyone, I know it is confusing, I know it is difficult to understand everything at one go, but please try to understand, because it is very, very, very important. Okay, now see this delta v delta x, that is the position and momentum or velocity obtained, is much larger and uncertainties are of real consequence. So what does it mean? Like, you know, whenever especially this macroscopic may, this uncertainty principle, it is negligible. Micro and macro. See, macro is something like, for example, ball. Okay, football. It is macro, right? Which you can see. Whereas micro, it's most of the time you won't be able to see them by your naked eyes. है ना? Yes. In the quantum chemistry, quantum mechanical model, which I have already taught you, I guess. Do you remember? We had taken a separate session on it. Yes. Micro is cricket ball. No. Microscopic is our electrons. Yes? So, in the next session, the Vyasha ma'am will be covering those topics again in detail, photoelectric effect and the quantum mechanical model of an atom as well. Okay? Yes. So, now let's just try to solve this. Maybe you will get an idea. Example. For an electron whose mass is 9.11 into 10 to the power minus 31 kg, right? Its mass is very, very, very small. So according to Heisenberg uncertainty principle, so this Planck's constant ka value hai, I didn't want to say this. I thought, you know, I'll give you as a homework question, but it is here. We have to solve it. 6.626 into 10 to the power minus 34 joules per second, and then 4. So pi is 3.141. You know the value, and 11 into 10 to the power minus 31. Again, it is its mass, 9.11 into 10 to the power minus 31. So this is the uncertainty. Like, I do not know the position, or I do not know its exact velocity. This will be the uncertainty in this micro-sized object, but here we have taken the example of electron. Clear? Yes? You got it? So we have this, right? We had this relation. What is that? Like uncertainty principle. So delta x delta p greater than equal to h by 4 pi. Now if you try to apply that for an electron which is microscopic, because it is uncertainty principle does not work for macroscopic, it is negligible. So what is the uncertainty? So this is the value, and how did we get it? We just substituted. We know the Planck's constant, which is a constant. So 6.626 into 10 to the power minus 34 joules per second, joule second, and then 4 pi ka value, to it is fixed 3.14. Goes 3.142, you can just write, and this is the mass. M stands for mass, and then we have solved it. Clear now? Yes. Okay. So how can we conclude this? So you cannot obtain the position and momentum of electrons precisely. Simultaneously, it is impossible. Okay, the precise statements of the position and momentum of electrons have to be replaced by the statements of probability. I can just tell you, maybe you will find it here, but I cannot be sure. That's the first point, that the electron has at a given position and momentum. So this is what we will be studying in detail in quantum mechanical model of an atom. Clear? Or did you find it difficult? Yes, huh? You know, like you have those shells, and then you have subshells and the orbitals. That is where the probability of finding electrons is maximum. है ना? We will just know the exact address of an electron, which we will be covering in quantum mechanical model of an atom. Okay? Okay then, so if you are okay with the topic, then are you ready to play the Menti? Yes or no? Shall we start? Yes? It's okay, it's okay, it's okay. Okay, you want me to summarize. So what did we learn? So about the de Broglie wavelength, and he stated that so even the electrons has dual behavior. That is what today's topic was, है ना? And we have this de Broglie wavelength, and he gave us the relationship between momentum and the wavelength. Okay, and then we came to Heisenberg's uncertainty principle. So according to that, simultaneously you can't know the exact momentum and position of an object. So when it comes to macroscopic, it is negligible, so leave it. And for microscopic, we even try to know the uncertainty in electron. Yes, okay Malhar, we will be doing that very soon. I'll only take a session on it. Okay, yes. So shall we start the Menti now? Please go back to the same Menti. I really hope you have not closed that window. Okay, yes, let me just, because I don't want to show you the link. Ready, everyone? Are you here? I will be still showing you the leaderboard. If you have not joined, please join. So on the leaderboard we have Polestar, Mark, Sakshi, Srilata, Harsimran, Harry Potter, Cincy, Hari, Malhar. Back in race. And before we move on to the next question, come on, make sure to hit the like button, share this video with your friends, and what else should you do? Subscribe to this channel if you haven't done it yet. Okay then, let's start. Good to go. So we have so many questions today, all the very best. Wave-particle duality is supported by electrons behaving as particles with ordinary matter, electrons behaving as wave when traveling through space, the photoelectric effect, all of the above. Have you joined? I started. I'm so sorry. Okay, yes, chalo. Whoa, and you are telling me you have not understood. Look at it. You're performing so well. Nice. Whoa. Acha, it was Tukka. Who was that second me? There were two Cincies. Next question. If waves can behave like particles, then particles can behave like a wave. This is the idea behind. What did we learn today? Rohini, is that for me? Hi Atul, hello. Come on, you still have 10 seconds if you have not answered or joined. Please join. Okay, let's see. Whoa, nice. What to do is, you can ask me anything. Today I'll be your genie. Ask me something. I will fulfill your wish because you guys are doing so well. On the leaderboard we have Polestar, Mark, Srilata, Harsimran, Cincy. What is this? The Google Cincy is not you. Then who is it? Sheet or sheath. Was it? Is it Sheetal? Yes. Sakshi, Harry Potter, Hari. Okay, so question number 6. Bio question. Pratyaksha, I don't think I remember everything, but go ahead. I'll try to. The Broglie equation I have shown you the equation. So what is the relationship between what and what? It tried to relate what and what. Momentum of a mass to its wavelength, or energy of a mass to its wavelength, frequency of mass to its wavelength, work function of a mass to its wavelength. This is easy peasy. I want all of you to answer. Come on. This is not fair. What happened, Suraj? What happened? 2, 1, and time's up. Hmm. 71% of you gave the right answer. This is nice. Question number 7. Ready? Yes, describe yourself with a song. Oh. That's a very difficult but very, very interesting question. Oh, nobody has asked me this before. The uncertainty principle applies to macroscopic, microscopic gases, none of the above. When the blood enters kidney, it is oxygenated. And when it comes out, it is deoxygenated. When it enters kidney or lungs? Wait. Yay! I am so happy today. That's nice. Yay. Microscopic, now we said it is negligible for macroscopic. All the leaderboard we have. Polestar, high five. Mark, high five, ma'am. Harsimran, Srilata, Sheetal. I feel like it is Sheetal, not Sheet. Cincy, Google me. Where is the actual Cincy? Okay. Sakshi, Harry Potter. Cincy, Hare Krishna. Question number 8. Which of the following rules or principles is responsible to rule out the existence of definite paths or trajectories of electrons? See, trajectories in which pathway is it moving? Okay, so we ruled it out. But what made us rule out that existence of certain fixed path where the electrons are revolving? Very good. Nice. So it is option D, right? Yes. Kya baat. Very good. Hanji, I will fulfill your wish. Let me just end the Menti. Okay? This was easy, right? It is easy because you have understood the concept. Hai na? Shall I go and ask my cousin brother who is in 5th grade, what is this Heisenberg uncertainty principle? He won't be able to answer, right? Okay, according to Heisenberg uncertainty principle. Look at your phone, come on, tell me. You know this, we have seen this. Last 10 seconds. 5, 3, 2, 1. Time's up. Very good. But how, like, I see 30 students here, but only few of you are playing. Huh? क्यों जी? On the leaderboard we have Mark Sheet, Srilata, Harsimran, this is Sakshi, Simsi, Suchi, Simsi, Bhumi. Who is in 5th position? Who is in 5th position? Who? I'm so sorry, I cannot see your name. There's a donut. Ha, you are Sheetal is second, fifth, after Hasimran. Arey? Ha, Polestar. Yay. Nice. So now, what did we learn in today's session is very important. I hope you have understood particle and wave nature of electron. See, we have not covered everything in today's session. Okay, so in the next session, which Divyasha ma'am will be taking, so she will be explaining you about the photoelectric effect, and she will be starting with quantum mechanical model of an atom. But from next week, we will be starting with organic chemistry, which is my favorite. So I will be focusing on organic chemistry and she will be covering the physical chemistry topics. Okay? Yes. I know you are all asking for organic chemistry. We had to start it. If you have any doubts, let me know in the comment section, and make sure to subscribe to the channel if you haven't yet. We have different series where we will be covering a lot of things, like, you know, we have Beyond the Books and A to Z series. What else? And we will be starting brand new series in the upcoming weeks. We have everything is planned. We just have to bring it in front of you. We will be doing it very soon. Thank you. Come on, hit the like button. आज तो 75 तो होना चाहिए यार. Target था 75. हाँ, I mean 100. Yeah. Now, if you wanna learn from me on the Vedantu Pro subscription, what you have to do is, where is it? Can you all see me? Yes or no? Yes. Okay. See, there are 1, 2, 3 Surabhis. Hello. What you have to do is, in the description you will find a link. So click on that. You can see, right? Select your class. I will be choosing class 9 and CBSE, because if there are any 9th grade students, so this will be helpful for you as well. If you are wondering what, like, you are anyway teaching on YouTube, like why should we get the plan? Firstly, our channel, we are not grade oriented, so we won't be covering or completing any curriculum. So it's a very general channel where we will be trying to teach you everything about chemistry. So if you want to learn CBSE ka syllabus from me or other amazing teachers who are there on the platform, then what you can do is you can get the subscription. So there are different plans like Pro Lite, Pro Classic, Pro Plus, but I would say, you can start with Pro Lite because that is enough for all of you. Like, because you will get live interactive online classes, test series and analysis, assignments and notes, doubt solving during class. That's a lot. So trust me, after the session, like 99.99% doubts will be solved, and if they are just spam messages, then only they will be ignored. And if you are not very sure, you can just try for 1 month. See, for 2070 rupees you will be getting, and it is unlimited live classes. So you can just divide it, do the calculation. It will be very less, and in that price you will be learning a lot from all the amazing teachers. We have Amrit sir, Abhishek sir, Deen Bandhu sir, Surabhi Ma'am, Harshpriyam Sir, Nikhil Sir. I am taking a lot of batches. So CBSE 9th and 10th grade students, if you want to learn, then you can join. Thank you so much. Yes. Chalo. And about Vedantu improvement promise, ma'am, I have taken the pro subscription, but like, what do you think? Will I improve or not? So we have taken that responsibility. We are so confident that there will be improvement in your performance. If you feel like there is no improvement, then you will be getting your course fee back without any questions. So that is what is VIP is, Vedantu improvement promise. So we believe in you. We believe in our teachers and the entire team. So if you also trust us, then you can just join the Vedantu Pro subscription. Take it up and then we will be waiting for you. Thank you so much. And in the comment section, very, very important, let me know how was today's session, if you have any doubts, and what is the value of Planck's constant. Okay, so as you know, whenever I read the comments, I like them and I reply to few interesting comments as well. So let us see who will get a reply from me and Elementary Chemistry by Vedantu channel. I'll see you very soon. Till then, please take care and stay strong, stay happy. Bye bye.